Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. Okay, 2018 question, another question on that paper on sequence and series, and this was question 9, so a long question. The diagram below shows the first 4 steps of an infinite pattern which creates the Sierpinski triangle. I'm not familiar with it. The sequence begins with the black equilateral triangle. Each step is formed by removing an equilateral triangle from the center of each black triangle in the previous step as shown. Each equilateral triangle that is removed is formed by joining the midpoints of the sides of a black triangle from the previous step. Whoa, okay. Step 0, it looks like one big black triangle. Step 0, step 1, they've removed the center of it. Step 2, okay, they remove the center of each of the black one like that. Okay. Step 3, okay, then they remove the center of each one of this. Right, okay. The table below shows the numbers of black triangles at each of the first 4 steps and the fraction of the original triangle remaining at each step. Complete the table. Step 0, okay, that's easy enough. Number of black triangles, 1. Fraction of the remaining triangle, fraction of the original triangle remaining, 1. So it's 100% there. Okay, number of black triangles in step 1, 1, 2, 3. Okay. A fraction of the original triangle remaining. Well, you've broken it up into quarters when you did this. You have 1, 2, 3, 4 quarters. Fraction of the original triangle, you've taken this one out, so I'm left with 3 quarters. Okay, number 2, number of black triangles. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so it's 3 for every original, so 3, 6, 9. Okay, fraction of the original triangle remaining. Okay, well, I removed a quarter of each black. So I removed a quarter of a quarter, and I did this 3 times. I did it once here, and once here. Okay, quarter of a quarter is a 16th. So I removed 3/16. Okay, so that was only in that step. There was already a quarter removed here. Okay, so there's 4, 8, 12, 16. Let me write that 1/4 as 4/16 in my head plus the 3. So I've removed 7/16. So what's left then is 9/16. God, I didn't even need to work it out. I didn't even see it there. Okay, so 9/16. So 1 minus 7/16. So I'm left with 9/16. You know what? Even though I didn't have to do it, there is no harm in doing it and figuring out where did they get that, because you have the same process to do here. Okay, but remember to fill in as much as you can, even if you can't work these out, fill in these ones. Okay, take as many marks as you can. Okay, so remember I said there's 3 black triangles in every original. So I'm going to go 3, 6, 9, 12, 15, 18, 21, 24, 27. So there's going to be 27 black triangles in that one. Okay, and then what's left? Okay, so what did I remove this time? Okay, well, I removed again a quarter, but it was out of each 16th. Okay. And I did that 9 times because there was 9 black triangles in the original one. Put that into the calculator, 9 by a quarter by a 16th. and I got 9/64 for that just there, okay? What did I remove the last time? Well, I removed 7/16. So plus 7/16 to that. And I removed 37/64. Okay, so what's left? Well, 1 minus that 37/64. So 1 minus answer on my calculator. And I am getting 27/64. Okay, so there's certainly a pattern going on here. You see this number ends up being the number on the top. If you're good at patterns, you'll spot this one. Okay, and then the bottom here is definitely a multiply by 4 going on. Okay, so that's how you fill in that table. And there's probably a lot of marks for filling in that table. So the next one said, write an expression in terms of n for the number of black triangles in step n of the pattern. Okay, so it's up to you. You can try and see if you can see. So it's the number of black triangles, okay? So again, I'm just going to clean off this. It is in the recording, okay? Right, so some people are really good at seeing patterns. What you do is you tend to write down your n values, okay? So these would be your n values. So when n was 0, my number of triangles was 1. When n was 1, I had 3. When n was 2, I had 9. When n was 3, I had 27. Okay, and you're looking for a pattern between your n numbers and your answers. Okay, now just a word on n is equal to 0 and 1 is your answer. Anything to the power of 0 is 1. Okay. Right, so how do I go from 2, n is equal to 2 to 9? How do I go from 3 to 27? Okay, well, these are all base 3 numbers. Okay, so in other words, that's 3 to the power of 1. This is 3 to the power of 2. This is 3 to the power of 3. He could be written as 3 to the power of 0. So that's why I tend to leave him to the end, because he can, I'll see if I can manipulate him given what I have here. Okay, so you can see the next one will be 3 to the power of 4. And then you compare your n number to what's in your power. So this is a direct 3 to the power of n. Okay, for example, if n was 2 here, I would be 3 to the power of n minus 1. So you just see what needs to be in the power to make it match. So an expression in terms of n then would be something like that, 3 to the power of n. Okay, you could try coming up with, yeah, no, that's the easiest way to do it. Okay, let's have a look at the next part. Step K is the first step of the pattern in which the number of black triangles, we're still on black triangles, exceeds 1,000 million for the first time. Okay, so our Tn was equal to 3 to the power of n. So we want to know step K. Okay, so t to the power of k then would be 3 to the power of k. And we want to solve that. What is k when the number of black triangles exceeds 1 by 10 to the 9? Okay, because what we need is in the power, you need to invoke logs. So we can use either of these two rules here, which would be the switch, or we could use this one here. Okay, so again, 3 to the power of k was 1 by 10 to the 9. Okay, I could use this rule here, which tells me that if I match the base number of a log to my base number here, these will cancel and I'll just be left with the power. So if I do log to the base 3, so I'm matching my base numbers here, of 3 to the power of k, so that's just this. What I do to one side, I have to do to the other. The log 3 and the 3 will cancel, and I'll be left with k being equal to log to the base 3 of 1 by 10 to the 9. Okay, and I put that into my calculator and I'll get my answer. Or of course I can do the switch. 3 to the power of k is equal to 1 by 10 to the 9. Let's match our letters. 3 is my A, k is my x. There's my A, that's where I'm matching. My power is x and my number is y. Okay, and then rewrite it using logs so that you get log my A is 3, my y is 1 by 10 to the 9, and that's equal to my x, which is k. And you can see you get the same thing. Okay, so whichever one of the rules suits you best. Okay, so log to the base 3, 3 to the power of k, log to the base 3, 1 by 10 to the 9. So they cancel. So I put that into my calculator. And again, make sure you're using the log button that will allow you to put in your own base. So I hit that button, I put in 3 as my base, and I'm 1 by 10 to the 9. And I have 18.86 is what I'm getting. So I need to exceed it. That's the critical value. So therefore, if I go to the 19th step, I will have exceeded 1 by 10 to the 9 triangles. Okay, step H is the first step in the pattern in which the fraction of the original. Okay, so we've switched to the other row in my in your table. So you always have to be careful if there's 2 rows in your table, which one are they talking about? So now we're talking about the fraction of the original triangle. Step H is the first pattern when it's less than 1/100th of the original triangle. Find the value of H. Okay, so let's write that out. That's 1 3/4, because remember we didn't have a formula or anything for this one yet. 9/16, 27/64, so on. Okay, so let's try and see what's happening here to go from one step to the other. So I'm going from 3 to 9 to 27. 3 3s are 9, 9 3s are 27. So we're multiplying by 3 on the top. What are we doing on the bottom? 4 4s are 16. 16 by 4 is 64. Okay, so it looks like to get from one term to the other, we are doing a 3/4. Okay, and I want to know how many steps will be less than 100. Okay, always remember to, sorry, I should have said, to calculate your common ratio here. You can get it from T2 over T1, or of course T3 over T2. So to get from one term to the next, how did I do that? Okay, I'm going to do T3 over T2 just to show you, because it's a little bit more difficult than T2 over T1. Okay, so if you put that into your calculator, when it's a fraction over a fraction, I go 9/16, and then I use the divide by sign, 3 fraction 3/4, and you can see you get 3/4, okay, which is your common ratio, which is another way of working out that piece in the middle. So this is the formal. I did it informally by looking at the pattern, so whichever one you want. That's how you work out your common ratio. Okay, so we have to solve that. When is that? That's a H there at the top. Sorry about my writing. When is that less than 100? And again, I'm going to use logs, and I'm going to do the same thing again. Log to the base 3/4 of 3/4 to the power of H is less than log to the base 3/4 of 1/100. Okay, and that cancels and it exposes that H that's in the power on its own. Hit that log button that'll allow you put in your own base, put 3/4 into your base. Make sure you're doing this with me to make sure that you're putting it in right in your calculator. Just don't take my answer for it. I'm getting 16.007. And we have to be less than it, so just about we need to go to the 17th term. Okay. What fraction of the original triangle remains after an infinite sum of steps in the pattern? Okay, it would imply it would be a sum to infinity. Okay, or if you think about it, if you keep taking away triangles from that, how much of the original triangle is going to be left after an infinite number of time? Well, it's going to be 0. Okay, there's going to be nothing left if you keep taking away triangles. So that's the answer for that one. Part D, the side length of the triangle in step 0 is 1 unit. The table below shows the perimeter. Okay, so what they're saying is that original triangle is 1 unit. You have to imagine an equilateral. Okay, so you get a perimeter of 3. The table below shows the total perimeter. Complete the table below. So in step 1 then, okay, I need to go back and see what's happening. Okay, so the length of him is a half. He's 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 a half. Okay, so I have 1.5 there, 1.5 here, 1.5 here. Okay, so I have 3 by 1.5, so I have 4.5 or 9/2. The only reason I'm writing it in as a fraction is because this one is in a fraction. Okay, now there's a couple of ways of doing the next one. They've given me my answer in the next one, which is 27 over what was it? 4. Okay, so what I think I would do in this one, rather than add it up, is I would do the following. I would look for the pattern. Okay, because it's getting pretty hard to see what the perimeter of all of those ones is. Okay, now you could work it out and you will get it. They're an eighth, each of them. You know how many triangles are in it and you work it out. It's 3/8 by the 27 will give it for you. So perfectly fine to do it like that. Or you can look at it this way. Okay, so I'm going from 3 to 9. That's a by 3. 9 3s are 27. So on my calculator, I'm doing 27 by 3 to give me 81 on the top. What's happening at the bottom? I'm multiplying by 2. So that's an 8, okay? So on the top, he's a by 3. He's a by 3. So he's going to be a by 3. And of course, he's going to be a by 3. So 81 by 3 is 243. And on the bottom, 16. Okay, so he's a by 2, a by 2, a by 2, and a by 2. Okay, and that just might be an easier way for working it out. Okay, or like I said, you can see that the length of each of these triangles, if they're a half, these are a quarter. Okay, and you know now that it's 3/4 for each triangle, and in step 2 I had 9 triangles. So 9 3s are 27/4. So that's where it comes out of. The same in this one, a half of a quarter is an eighth. So each of those small triangles have a perimeter of 3/8. And if you multiply 3/8 by 27, you're going to get 81/8. Complete the table below. So that's that piece done. Okay, find the total perimeter of the black triangle in step 35 of the pattern. Step 35 of the pattern. Give your answer correct to the nearest unit, okay? So I'm going to write out my pattern, which is 3, and I might put it over 1, and 9/2, 27/4, 81/8, 243/16, and so on. Okay, so if I try and come up with the formula for this, well, on the top, it's a 3. over 2. And then I'm just wondering, so this is n is equal to 0, n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4. Okay, so for example, when n is 1, how do I force the top to be 9? Well, it looks like I do an n plus 1. Because when n is 1, then I'm getting 3 squared. And on the bottom, I have just 2 to the power of n. So let me test it to see, does it work on this one? When n is 2, I get 3 to the power of 3 over 2 squared. Yeah, so that's working. So I hope that makes sense. Again, what did I do? Let me just rub that out and explain it again, because I was just figuring it out there rather than explaining it. I've written out my pattern. Okay, and I'm wondering now, I'm looking for a formula. It would be great instead of having to write out 35 steps, and it's perfectly okay to write out 35. It's just 35 is a lot. I'm wondering, could I come up with the formula so that I can go T35 then equals. So that's what I'm doing. So I'm looking at the top. I'm labeling my terms T0, T1, T2, T3, and T4. And then I'm seeing how do I get from one to the other. Okay, so on the top, I know there's a multiply by 3 going on the top. I know there's a multiply by 2 going on the bottom. Okay, so then I have to figure out, is it to the power of n's or what when I go from one to the other. So if he's only, I need him to be squared. So I'm testing him for a random term. This one here. So I need the top to be squared to give me 9. Okay, but I'm only on n is equal to 1. I'm only on T1. So therefore I need an n plus 1 to force that to be squared. On the bottom, my n is 1. I'm on T1. 2 to the power of 1 is 2. So I just need the bottom to be an n. Okay, so that's my Tn term. So then T35 would be 3 to the power of 35 plus 1, which is 36, over 2 to the power of 35. If you put that into your calculator, 3 to the power 36 over 2 to the power of 35. And you get 4, geez, a big number, 368,328.818. 4 million. Give your answer correct to the nearest unit, 4368329. Okay, part 3. Use your answers to see part 2. What was that? Sum to infinity of the original fraction being 0. Okay. Use your answers to that and to D part 2 to comment on the total area and the total perimeter of the black triangles here. Okay, well, the total area we said was going to be 0 if we went to infinity. Okay, so as n tends to infinity, which means we keep stripping away that triangle, we're going to be left with nothing. So the total area is 0. However, the total perimeter, because we now have more triangles to go around, well, you can see the pattern, the number's getting bigger. So that's 3, that's 4.5, that's 6, 12, 8, 6 something. And anyway, this one's 4 million. Okay, so the total perimeter will tend towards infinity, which is the easiest way of writing down a really big number. If you've enjoyed this video, then why not join us in IT Sligo and use maths in practice. In conjunction with industry, we've designed an exciting new program in electronics and self-driving technologies, which uses cutting-edge techniques such as artificial intelligence, computer vision, and virtual and augmented reality. You'll need a H5 in maths to qualify. Check out the link below.